That is, what is node and what is communication link? A node is nothing but a computer or a printer or any device that capable of sending or receiving data generated by other node in the network. The best example here, the node is computer, server, printer, security camera and many more such as switches, bridges and routers. A communication link can be a wired link or wireless link. That is, communication link carries the information from one node to the another node, from source to the destination. For example, there are two computers called as nodes. These two computers can send data as well as receive data. These two nodes are going to exchange information, but for exchanging information they are depending upon cable, that is here link. Cable is nothing but a link, that is our physical medium which carry information from one end to the another end. Let's take an example of two smartphones. They want to exchange data, that is two nodes, that is our two smartphones. There is no physical connectivity. How can be that communication be established? This is possible through wireless telephony. If that is the case, who is the carrier of information? Obviously, air is carrying the information from one smartphone to the another smartphone. So, air is the link that carries the data. There are two types of communication link. First one is wired link and second one is wireless link. The best example of wired link is our cable, and wireless link best example is through air. Let's move towards our next topic. Basic characteristics of computer network. Computer network should be fault tolerant, it should be scalable, it should provide quality of service and it should always provide security. What is fault tolerance? Fault tolerance means the ability to continue working despite failure and ensure no loss of service. For example, if we have a computer network and if there is a problem inside the computer network, but still the computer network should work even after failure and thereby no loss of service. Let us consider real scenario. If I want to travel from home to the college, that is my sweet home to the college, that is source to destination. If there is blockage in my regular route, then I will find out the next available route to go to the college if there is blockage in regular route. This is the concept of fault tolerance, that is finding the next available route to reach our destination. Now second point is scalability. Scalability is nothing but the ability to grow based on the needs and have a good performance after growth. If there are 10 computers in a network, again 10 computers are added to the network. This network should work as like the same even after adding computer. For example, scalable network is our internet. Many new devices connected to the internet and handling communication. Internet handle this is very perfectly. It is always give scope for newcomers. Here scalability grow based on needs and perform good after growth. The third point is quality of service. It is the ability to set priorities and manage data traffic to reduce data loss delay. For example, if router receives 2 packets at a time, packets are two data packets at a time. This router should know which data packet process first. This is called as set priority. Here best example is voice over IP phone, VoIP. VoIP phone is different from our traditional landline phones. This VoIP phone sends voice data through the internet, whereas our traditional landline phone sends data or voice data through the dedicated telephone network. In simple language, the VoIP phone like our WhatsApp call. In WhatsApp call, our voice data sends to the destination through the internet, but not through the telephone network. Let's consider one scenario here. Person A sends email message to one server through router 1. At the same time, there are two guys talking over voice over IP phone, that is VoIP, through internet. The situation is two guys are sending data at the same time, where this router 1 experiencing both the traffic at the same time. First one is the email traffic and another one is voice traffic, that is the real-time communication. The question is which data the router 1 will give the priority, whether the real-time communication or to the email data. Actually, router 1 will process VoIP phone data. Why? Because it is an real-time communication. In real-time communication, delays are not acceptable, whereas delays are not problem in email communication. A delay of 1 second in email communication is not going to harm communication, whereas delay of 1 second in real-time communication matters a lot, and that is why this router 1 will give priority to real-time communication than normal communication. When router experiencing two different kinds of data at the same time, the router should be able to know to which data it should give priority. This is called as quality of service. It handles loss and it handles delay. Fourth one is security. Security is nothing but the ability to prevent unauthorized access, misuse and forgery. And security provides confidentiality, integrity and availability. Data communication. Data communication are the exchange of data between two nodes via some form of link, that is transmission medium such as cable. In given figure, consider two nodes, that is node A and node B, exchanging data via link, that is our communication link. It is also known as cable. Exchange of data. Exchange of data is nothing but travel or data flow. Travel data from one node to the another node, that is from node A to the node B. As I said, data flow is nothing but flow from one node to the another node, that is from one end to the another end, from source machine to the destination machine. There are three types of flow. First one is simplex, second one is half duplex and third one is full duplex. In simplex data flow, communication is always unidirectional, that is one device can transmit and other device will receive. The best example here is keyboard, traditional monitors. Second one is half duplex. In half duplex communication, that is communication is in both direction but not at the same time. If one device is sending, the other can only receive and vice versa. The best example here is walkie-talkie. In walkie-talkie, we can talk and listen, but we can't talk and listen at the same time. Last one is duplex. It is also known as full duplex or duplex. Communication is in both directions simultaneously. Device can send and receive data at the same time. The best example here is telephone line. We can talk and listen at the same time. What is protocol? Protocol, it is a set of rules that govern data communication. In simple word, protocol means rules. Protocol that are used in network communications are: first one, message encoding; second one, message formatting and encapsulation; third one is message timing; fourth, message size; and fifth one, message delivery options. Now first one is message encoding. It is nothing but first source computer generate a message, then it gives that message to the encoder in order to generate signal. Once the data is converted into signal, now it is given to the transmitter. Then transmitter sends the data to transmission medium. Transmission medium takes data to the receiver and receiver receives the data. After receiving data, it decodes that data. After proper decoding, it means the message has reached the destination. Now second one is message formatting and encapsulation. In message formatting and encapsulation, sender and receiver must agree on some format. It encapsulates the information to identify the sender and the receiver rightly. Both sender and receiver must mutually agree upon certain format, which we call that is formatting. At the same time, when receiver receives the data, which should identify who has sent this data, we are going to add some information with the data in order to identify the sender and the receiver. We are not going to send just data as said. We are going to encapsulate certain things like source information and the destination information with the data, so that the right sender and the right sender and the right receiver identify. Third one is message timing, that is flow control and response timeout. Now what is flow control? Let's assume for example, the guy A is very fast and the receiver B is very slow. Sender A sends fast, that is, it can send data at very high speed. What about receiver? He can't handle that speed. If there is no flow control mechanism, sender A can keep on sending data, but receiver B can't receive that data. So the entire communication will become useless. It is the responsibility of protocol to provide flow control mechanism. And second point is response timeout. Sender is sending some data. The receiver has to acknowledge the data. When the acknowledgement is sent back to the sender can understand that the data is received by the receiver, that is our destination. If the acknowledgement is not received, the sender have to wait certain period of time. After the expiry of time, the sender will be retransmit the same data, so that we ensure guarantee of delivery of data packet. It is the responsibility of protocol to tell how much time this computer should wait for an acknowledgement. Fourth one is message size. Human break long message into smaller parts or sentences. Long message must also be broken into smallest pieces to travel across a network. If there is a very big message to be communicated to the destination, humans break that message into smaller parts. The sender has very big content to be sent, then it breaks it into the smaller parts. Likewise, our computer should also do that. If the capacity of link is very small but the data to be transmitted is very big, this computer should break the big message into the smaller units which this transmission medium can handle. Let's take an example. If sender has 100 KB of data but the link size, that is transmission link size, is 50 KB, then sender break that message into the 10 parts, that is of 10 KB each. Now last point is message delivery option. There are 3 options are there. First one is unicast, second one is multicast, and third one is broadcast. In unicast means one sender and one receiver. If the sender is sending the data to the exactly one destination, it's called as unicasting. Now second option is multicast. Multicast is nothing but the sender sends data to the set of receiver but not to all. It's called as multicasting. For example, machine A sends data to B and C but not all, B to Z. That is called as multicasting. Set of receiver but not to all. And broadcast means the sender sends the data to all the participants in the network, then we call as broadcasting. For example, A sends data to all the machine, that is B to Z. That is A send data to all the participants in the network. Now, what is peer-to-peer network? In a peer-to-peer network, every node is called as peer and they are in a equal level. That is, no one is superior and no one is inferior. The problem with this is there is nobody is superior and nobody is inferior. That is, there is no any centralized part to administration. Whatever rights one PC have, the other PC have the same right. It is suitable for smaller application and not for large application. And peer-to-peer network is a not scalable one. Client-server network. Here we have centralized architecture, that is centralized administration. Here we perform request response model. Client requests for something, server will give response. It is scalable. The problem here is server may be overloaded. Now let's see the various components of CM. The first one here is nodes, second media, and third one services. First one, node. There are again divided into two types: end node or end devices and intermediate devices. Media again further divided into two types, that is wired or wireless, or guided media or unguided media. Here node is nothing but end device, that is going to be starting point of communication or end point in the communication. If two devices wants to communicate with each other, the device which initiates this communication is an end device, and the device which accepts the communication in final state, it is an end device. And these two end devices communicate with help of semi-intermediate devices. The best example of end devices are computers, network, printer, VoIP phones, security cameras, etc. And intermediate devices or intermediary nodes that just forward the data from one node to the another node. They are going to be placed in between end devices. The best example of intermediary devices or nodes are switches, bridges, wireless access point, hubs, router, repeaters, or cell tower, which only forward the data from one node to the another node. Next point is media. Here media is nothing but a link that is going to carry the data from one side to the another side, that is from sender to the receiver. The best example of media, that is link, wire link and wireless link. It is also known as guided media or unguided media. The example of wired media are Ethernet straight through cable, Ethernet crossover cable, fiber optic cable, coaxial cable and USB cable. Ethernet straight through cable and crossover cable comes under twisted pair family. If you want to connect different devices, we have to go for Ethernet straight through cable. And if you want to connect two devices of same kind, for example two switches, two routers or two computers wants to be connected to each other, then we have to go for Ethernet crossover cable. In Ethernet cable, data is going to be carried in terms of electrical signals. In fiber optic cable, the data is going to be carried in terms of light waves. We know that light is the fastest one in the world. This cable takes data in the form of light wave. This is fastest mode of wire communication. Now last one is coaxial cable. This cable mainly used for audio and video communication. We can see this cable in our home. If you have a set-top box, just go and see set-top box which connects the dish antenna and the set-top box. This cable also carries data in the form of electrical signals. USB cable, that is universal serial bus cable. This cable is used to connect computer and the smartphones. In wireless media, two or more devices are going to communicate with each other but without the help of cable. Here air is the medium that carries the data from one node to the another node. In wired network, data is converted into signal. It may be electrical signal or light signal. But in wireless network, data is converted into waves. The best example of wireless media here is first one infrared wave, second one radio wave, third one microwave, fourth one satellite wave. Last component is services. First one is email service, sending receiving mail. Second, storage service, for example Google Drive. Third one, file sharing, simple sharing of file. Fourth one, instant messaging like our WhatsApp. Next, online gaming. Sixth one, voice over IP, that is our voice call. Seventh one, video telephony, that is our video call. And eighth one is World Wide Web, that is surfing internet, that is our services of computer network. Computer network classify into three categories. First one is LAN, second one is MAN and third one is MAN. Now what is LAN? As the name implies, local area network. Local means it's restricted to a limited area, that is small network is said to be a local area network. A local area network is a computer network that interconnects computer within a limited area such as a residence, school, laboratory, university campus or office building. Next one is MAN, Metropolitan Area Network. A metropolitan area network is a computer network that interconnects user with computer resources in a geographic region of the size of a metropolitan area, that is our city. The best example, two branches in a city connected in a man, or two land connected with the help of man. Last one is WAN, that is wide area network. A wide area network is a telecommunication network that extends over a large geographical area for the primary purpose of computer networking. Telecommunication, that is any communication at distance, called as telecommunication. Let's move towards next topic, that is network topology. Network topology is nothing but arrangement of nodes of a computer. Topology means simple layout. There are two concepts, physical topology and logical topology. Topology means layout. Physical topology, placement of various nodes. Nodes is nothing but a computer or end device. And logical topology, it deals with the data flow in the network from source to the destination, from node A to node B, or device A to device B. Various network topologies are: first one bus topology, second ring topology, third one is star, fourth one is mesh, and fifth one is hybrid. Let's begin with first one, that is bus topology. All data transmitted between nodes in the network is transmitted over this communication, that is common transmission medium, and is able to be received all the nodes in the network simultaneously. That is nothing but a signal containing the address of the intended receiving machine travel from a source machine in both directions to all machines connected to the bus until it finds the intended recipient. A ring topology is a bus topology in a closed loop. Here, peer-to-peer LAN topology, two connections are there, one to each of its nearest neighbor, and ring topology are unidirectional. Sending and receiving data take place with the help of a topology, and no one is carrier. All nodes sides, that is peer-to-peer. Data. Then token move to the next node, and this topology called as token ring topology or simple ring topology. It is sent. It's easy to design and implement. It is a centralized administration and it is scalable one. Mesh topology. Each node is directly connected to every other node in the network. It is fault tolerant and reliable. That is, it is 100% fault tolerant and reliable, because suppose if there is a link failure and it has another way to reach the destination, that is so many way to reach the destination if in case link failure encounters. Hybrid topology is nothing but one or more topology is called as hybrid topology. We can see the combination or combining two or three topology means hybrid topology. Here bus topology, star topology, and ring topology combine in a single unit called as hybrid topology. This is all about basic concept of CN. Thank you.